All right, I guess we are good to go. Good afternoon, morning, or evening, everyone. Hope you guys are enjoying Digital Overdose Con. It's a nice Saturday morning here in the United States of America, and welcome to my presentation. All your modules are belong to us, which is a breakdown of Python module hijacking. I'm really excited to give this talk. I hope you guys are excited. We're going to get technical. We're going to dive deep into things. It's going to be a really, really fun time. So I hope you enjoy the ride. But first of all, you got to be like, wait, who's this random dude talking to me about all this information security stuff? Why should I trust him? Well, let me tell you a bit about myself. My name is Sam Ferguson. You may also know me as Affine Security if you know me on Twitter or on Discord. I am currently a senior at Ball State University in Muncie, Indiana, in the U.S. For all you non-American people, that's fourth year. I don't know if it's different elsewhere. Anyway, I study computer technology, so a lot of my focus is on system administration, network administration. That's most of what my background is. I'm also going to be an IT leadership development professional at CVS Health, which is a healthcare company in the United States. I'm really excited about that because I'm going to get to focus on security because I love security. I'm an aspiring ethical hacker, pen tester, red teamer, all of those things. I love the offensive side of security. Got love from a blue team, but big fan of the offensive side of things. And I'm a CTF enthusiast. I like doing a lot of CTFs, getting involved. Things like Try Hack Me, doing the Hack the Box one next weekend. It's going to be a lot of fun. But that's not what you came here for. You don't really care about the random guy up in the corner. You care about this presentation, this talk about Python module hijacking. Quick disclaimer, though, before we go into that, this presentation does not represent the views of any of my past, present, or future employers. All the views are my own. Get that out of the way just so someone doesn't come for me. So today's agenda, we got some great topics to talk about. We're going to be talking about what Python modules are, how Python modules work, how we find Python modules, well, how Python finds it, how does Python module hijacking work, and how we can automate this. Now, I'm not going to give you all of the answers to everything right away, and that's where a little challenge for all of you comes in. I want you to put on your hacker hat, put on your black hoodie, get out your laptop, boot up your Kali Linux, whatever it is, and I want you to think through my explanations because I'm going to break down just from a technical perspective what Python module hijacking really entails. And I want you guys to see if you can figure out how to exploit it before I explain. If you figure it out, that's great. If you get the technical details, you know exactly what commands, you can pull up your terminal right now and run it. Awesome. If you get a general idea of what to do, that's great too. Don't figure it out. It's okay. You're going to learn. Either way, I want you to be thinking to try and figure out how exactly am I going to hack into the machine? How am I going to break in as I explain things? Sound good? All right. Sounds good. Let's get into it. So first off, what in the heck are Python modules? Well, Python modules are simply files, and they're files containing two different types of things: Python function definitions and executable statements. You may be like, hold on, Sam, this is code. I don't know code. I don't know code either. Don't worry. You don't have to be a coder in order to figure out how all this stuff works. You really don't. You just need to understand some basic logic and be able to read things. So if you can do that, you should be good. So I've got a quick example here. This is from a Python module called OS. If you work with Python, you're probably familiar with it. If not, we'll explain some things within it. So at the top right here, where you see def_get_exports_list, that's an example of a function definition. That def there is defining a particular function. And these are little snippets of code that can basically be called when the script wants to do something in particular. So instead of running everything all at once, you can have these definitions to run very specific sections of code at a time. It's really, really useful. And then down here, you have just your standard executable statements, which are going to get run when the module itself loads. So this one here, we can see if POSIX in names. So in the OS one, OS, as the name implies, works with operating system level items. And so this is just kind of checking to see if we're running a POSIX system. So think Mac or Linux, or we're running later down, it checks for NT systems, so something Windows-based. So those are really the two things that Python modules do. And you might also wonder why exactly we would use these Python modules. Well, think of it like this. if I was writing code and I wanted to run a program and define exactly what time that program ran at, I didn't want to have to manually copy paste someone else's code to get the current time and to run a program into my giant script. Instead, I can just use modules that are pre-built and use a simple single line entry in my code to get those modules to run. Well, what is that single line entry? That is the import function that Python modules have. So modules can be imported into a Python script in two different ways. They can either be imported with a standard import statement or with the _import . And imports do two different things. They search for a named module as defined, and it binds the discovered name to the local script. That is imports only. Now, if you don't know what exactly that means, don't worry. We're going to break it down right now. So here's a quick example. On my left here, you're going to see that I've ran Python just in my terminal, and I've done import OS, import that operating system module that I talked about. And as you can see here, I can run os.getcwd, and it will get the current working directory that I'm in. And I can run that again as many times as I want because it has imported all the items within OS, all those definitions of functions and executable options, and it's running the ones that I want. Now, if you look over here on the right, I use the _import method, _, and then OS in a string. So got these little quotes around it, and then dit.getcwd. And I run it and it imports the current working directory, gets my information. But if I run it again, we'll see that we get a traceback error because the name OS isn't defined. And this is the difference. This is the defining, the linking to the local namespace that I was talking about. When I do import OS, that name OS is now linked to that module, no matter where in the script I use it. It will always be linked to it. But using the __ method only imports that for just the execution of that command. So if I try to do OS later, it doesn't know what it is because it's not been linked to the local space. So if you only want to use a module one time in your script for whatever reason, you use the __ method. But if it's defined multiple times, you would use the import OS function. And that's pretty much how exactly they work. Now, there's also two different types of modules in Python that is important to note, because importing can come from various places. And the two types are built-in and from files. So built-in, as the name implies, is built into Python. It's something that's just built into the program itself. But I will tell you right now, just so you don't go down any rabbit holes, they're not vulnerable to module hijacking. There's not really a way that we can modify the Python binary itself, or at least that's way above my head. Too smart for me. So the one we'll mostly be focusing on is from files. And modules are stored in just a standard Python file. They're, for a really simple generalization, pretty much like any other Python script that you might create. And they're also usually stored in a specific path. And let me show you kind of how you can figure this out. So here, I've got another quick little screenshot, ran some Python 3. And I've imported two different modules. I've imported the module called sys and the module called OS. So now if I just run those module names on their own, I can actually find out some information about them. And the module sys we can see is defined as built-in. So this is one of those built-in functions I was talking about within Python. It's just within the program. But if you look at OS, when I run OS, we see that module OS is from /usr/lib/python 3.9/os.py. So we're actually getting it from a specific Python file within our operating system, within our file structure. You might be asking, Sam, how does Python know where to look? How does it figure it out? Does it pull it out of thin air? Does it do abracadabra, alakazam, and it just picks one? Does it play eeny, meeny, miny, mo to figure out which module to use? No, it's a computer. There's some logic to it. And Python finds modules using something called the Python path. And Python path is nothing more than an environment variable. If you're not familiar with environment variables, they are just variables that are used at an operating system level for programs to pull information from. They can define things like what kind of terminal you're using. Are you using Xterm 256 color terminal, or what kind of shell are you using? Maybe you're using bin bash, maybe you're using bin zsh, maybe you're using bin fish. And this is information that applications want to know about and can be really useful. And Python is no exception. It uses the Python path. And so Python path lists directories that Python will search for modules in. And if you know about the normal just path directory on Linux systems, or really on Windows systems as well, it's basically the same concept, but for Python. But if not, I'll explain it in a moment. And let's look at here this output. So I have import sys for I in syspath, print I. This is just to make the output look nice. You could run just sys.path and you get this information. So we can see here we've got lib python 39.zip, Python 3.9, 3.9/lib download, and Python 3.9 site packages. That's really cool. It's helpful and stuff. But the one thing that's you really want to note is this here, this blank space you see between the ... and the first .zip entry. That is blank, but actually means the directory that script is being run from. So Python will first look for your current directory, where your script is being run, or your Python program is being run, try to find a module there, and then move on to the rest of the items in the Python path. Very important to note. And with that, we're done with the technical breakdown of Python module hijacking. So, did you figure it out? Did you figure out how to hack the system? Do you know how to do module hijacking at this moment? Take a minute, think about it. See if you got it. Last minute computation, last minute processing. And if not, that's okay. Let's dive into it and figure out how it works. So Python module hijacking. There are three main options for module hijacking, which is incorrect permissions, writable Python path, and env keep plus equals Python path. So let's look at all three of these. So incorrect permissions basically means if there's a writable module that a script is using, it's vulnerable. And I will note that the code must be placed in an area that is run. Not all modules are going to run every single thing on start. There's only certain items that they might have to run. So you might have to do a little code analysis, a little trial and error to see what will work. And your goal here is to modify a vulnerable Python module. So find a writable modules, insert malicious code, and then execute the original script. Now, this is great in explanation, but what if we actually got to see this in action? Yes, dear viewer, I have made my sacrifices to the demo gods for this presentation, and we have a demo, and it's gonna work, I hope. Fingers crossed, let's go. All right, so DOvercon 1, we're here on our first user. Let's take a little look. There's an interesting directory here called hashgen, and we'll note that the privileges show that it's owned by a user called DOvercon2. So we already know we can't write to it. Whatever, not a problem here. So we'll go to hashgen, and if we look here, we're going to see that we've got a couple Python files in here. Well, one Python file, hashgenerator.py. So let's read hashgenerator and see what modules it's importing. So we've got three here. We've got OS, we've got sys, and we've got hashlib. Now I'll tell you, sys is a built-in, as we know, so we can't really use that. OS is weird and just doesn't like being injected at all for whatever reason. I really don't know why. But whatever, we're going to ignore it. Hashlib's the one that we're going to be interested in for now. So let's go check out hashlib's permissions. So we're going to go to, well, first of all, what directory we're going to go to? Let's check our Python version, Python tech v. Whoop, I have Python 3, smiley, Python 3. So Python 3.8. So we're going to go to ls-tech-l/usr lib Python 3.8 / and let's just go directly to hashlib.py, which is in there. Let's check our permissions. Oh, well, that's interesting. The DOvercon 1 group can write to this file. Evil laughter, insert it here. It's time to exploit. So we are going to go to vim usr lib Python 3.8 hashlib.py. We're going to ignore this giant wall of comment that is here because Python. And we're going to do a little thing here, which if you've done Python exploitation in pen testing at all, you probably know what I'm about to do here. but it's the classic import pty dot spawn / bin bash, which is simply a really easy way to import the pty module and spawn a new terminal session. All right, that's cool and all, but the second part of this exploit actually comes from sudo privileges. Now, there's a couple ways that we can exploit Python module hijacking. I'll go over those later, but effectively, one of the ways is being able to run a program as another user. So we're going to do that now. You can see here as dovercon2, I can run things as a different, I can run a program as dovercon2. So let's do sudo tacu dovercon2. And we're going to copy and paste this because I didn't type it out beforehand like I should have. And then we're going to copy the rest of it. It's really long, but I promise it's for a reason. Boom! Look at that. We are dovercon2 because when Python looked up in the Python path, it found hashlib, it ran the module, but our little nefarious evil script ran, and we are officially the next user. So that's awesome. All right, back to the PowerPoint. Let's move on to our next exploit. So Python module hijacking part 2, writable Python path. Now you may hear this referred to as Python module poisoning. It's another name that I might mention, but writable Python path, module poisoning, they're the same thing. So as I mentioned earlier, Python will look through the path first to find any modules. And if anything in the path is writable, for example, the directory that script is run from, we could make a malicious poisonous module there and have Python import it directly from there. So our goal is, of course, to create a malicious Python module. So first, you want to find a writable directory that script is running from. Second, we're going to create our malicious module. And third, we're going to execute the script. So let's go on our wonderful dovercon2. And we can see here we've got a module called a Python script called b64 generator. That's cool. Let's read b64 generator. Okay, it imports base64. Gotcha. We're also in the home directory for dovercon2. So let's check right quick. Aha! dovercon2, as expected, is writable by the user dovercon2. So let's do vim base64.py. I import pty dot spawn / bin bash. You're going to be used to this by the end of this presentation. So we've got that. We'll quickly make that executable just in case and clear that. So now we've got our base64 module here. And again, if we look at our sudo privileges, we can run this as dovercon3. That's pretty sick. So let's do sudo tacu dovercon3. And we're going to paste this in here and run it. And voila, ladies and gentlemen, we are in dovercon3. We are now that user. So as we saw, we made that malicious Python module in the directory the script's being run from. Because of Python path, it looked there first, imported our base64, and ran our program. And we are officially in dovercon3. We are one step away from officially rooting this box, which is awesome. Now, the third option is really cool. It's end of a keep plus equals Python path. So this works with the environment variable Python path itself. And environment variables are definable really easily. In Linux, you can do something like export Python path equals whatever. But it really only works for that particular session. And that's an issue if we're trying to do something like sudo or make it work for a different user, because Python will, or Linux rather, will just ignore that. It'll say, no, you can't pass this environment variable. It's only for this session. But if the end of keep option is defined, it means that we can keep that environment variable when running a program as a different user. So our goal here, again, is to create another malicious Python module. So we can find any writable directory, execute the command, and set the environment variable in that command. Now, this one makes a lot less sense explaining it, so it's better to just show it. So let's look here. ls-tech-l. We've got a folder owned by root. Okay, so we can't write to it. We already know that. That sucks. All right, ls-tech-l. Okay, we've got testing.py. Now, if I run sudo tech-l here really quick, you're going to see that I have the end keep plus equals Python path in here. So that's very interesting. So let's cat testing.py really quick. You can see that it imports the module date time. Now you might also see this from date time, import date time. That's basically sometimes modules will have submodules, so to speak, and you can import just one part of that module, which is really nice. But regardless, I'm going to make a malicious file in wherever I want, and a classic one is /tmp. It's usually writable. So we'll make one called datetime.py. I import pty, say it with me all, pty.spawn /bin/bash. There we go. Very nice. chmod plus x, make that thing executable. Woohoo. All right, very cool. So again, sudo tac-l, whoops, of course, sudo tac-l, and we can run this as root. So again, we can run this as root. So we're just going to do sudo. Like here, we're going to pass our Python path environment variable and make it /tmp. So instead of that output of sys.path I showed you, where it was the current directory and then lib and all that stuff, it's only going to look in tmp, which is where our malicious module resides. So we're going to paste in this command. And ladies and gentlemen, we have achieved root access. We are in the machine. So awesome. We've successfully rooted using Python module hijacking. And I know some of you might be out there be like, Sam, you had to type so many commands to figure that out. I hate manually finding everything. Manual enumeration sucks. And dear viewer, I hate it too, which is why I made your life easier by making a script called PiSnatch, which is a module hijacking script that covers all 3 exploitations. And you can put it on any machine and very easily figure out what modules are injectable or exploitable without needing to install anything extra. So I'm going to exit really quick here. We're going to go back, see all of the failures from things, which is annoying. Okay, whatever. Cool. Yeah, I didn't do it. Error checking on the scripts. That's fine. Doesn't matter. So I'm going to go to dovercon2 here really quick. And I have a hidden directory called PiSnatch. So we're going to cd to .PiSnatch. And we're going to run /PiSnatch /base64 generator really quick. And we've got our little output here. So as per usual, infosec got to have some cool ASCII art to start. So first of all, it will check if our home directory is writable. And it says, awesome, it is writable. And there's an awesome module in Python called, what is it now? It's called Module Finder. And Module Finder will find all of your modules that are useful, that are used by that script. And so here's every single one that you could potentially exploit. And it'll also do some quick checks if the imported modules are writable and sudo tac-l checks, which aren't applicable here. But yeah, it's a really sick script. I was pretty happy with it. Does some cool stuff. And with that, guys, that is going to bring me to the closing of this presentation. I know Nico was looking questionably at me like, come on, dude, hurry it up, get it done. So if you guys want to connect with me, reach out to me on Twitter at @AFineSecurity, LinkedIn /in/AFineSecurity, or Discord Afine6730. I'm more than happy to talk with anyone who's passionate about information security, red team or blue team. I love talking to everybody. It's an awesome time. Please check out my blog, afinesecurity.gitlab.io. It's a fun blog. I try to post there when I can, mostly write-ups and other information. And you can check out PiSnatch here. Actually, I'm going to go to this really quick. I'll drop this in YouTube chat really quick. Throw that down there. So there's GitLab. There's my link to PiSnatch. You can check it out. Pretty basic, but if you want to use it, be sure to test it out. And that's pretty much all I got. So I'll hand it over to questions. Any questions that we got?
Hey, Sam, thank you so much for that fantastic presentation. You do have a couple questions. Atomic, would you like to start us off, or do you want me to start?
Yeah, I'll start it off since it was, well, my question. So a few languages, let's say, for example, JavaScript. I know a lot of people hate on JavaScript. When you import a script via HTML, you can add something called a integrity flag, right? Which basically cross-checks your integrity hash versus your file. Does something in Python like that exist that could potentially stop module hijacking?
That's a great question. I haven't really looked into the countermeasures for it, to be honest. And from my just rudimentary research of module hijacking, I haven't seen anything particularly mentioned that's like, hey, you shouldn't these shouldn't be injectable. But a lot of the security countermeasures that you can do are relatively simple. Make sure that the modules themselves are only writable by root. Make sure if a script is being run in a certain directory that proper permissions are set so you can't get access to that other user account. And then make sure sudo permissions and such as the end of keep stuff and just running the program are in place. So there's things you can do from that perspective, but I'm not sure if Python has anything built in that will solve that issue.
Alrighty. And then follow-up question. Let me actually get to the question area. That probably be helpful. Have you ever applied this outside of the live demo? Like, have you ever had to do this in your day-to-day work or etc.?
So I actually found out about this from doing a CTF on Try Hack Me. If you're interested in trying it, it's called the Wonderland box. It's a real challenge, but that's where I was first introduced to it. So it's really interesting. As far as practical applications, I'm not a pen tester by trade. I'm just a student, so I haven't done too much of it from a work perspective. But I mean, it's potential. You never know. A lot of people, I mean, from a student perspective, you're like, oh, how could this possibly ever exist? And then you talk to a pen tester, like, yeah, I've seen this like 5 times or whatever. So, I mean, I personally haven't seen it or heard of it in a pen testing scenario, but you never know. You've seen crazier things happen in a real live environment.
Mm-hmm. Makes sense. And there's a final question. How to use environment variables? I don't understand the concept.
Yeah, okay, so let me see if I can go to the terminal here. So let's go really quick, and I'm going to run env. So this is all of the environment variables, and they're basically, like I mentioned, storing information about the system. So you can see I've got my shell here. I've got things like my present working directory, the log name, home directory, language, and stuff. And so basically, the system will store a bunch of information about your current session. And you might see environment variables used for various reasons. Sometimes, for example, proxies. If you have a proxy at your work that you need to access, you might store the proxy URL in an environment variable called http_proxy. It's really useful. A lot of programs will check for that. And a quick example, like if I wanted to export, if I do export shell equals /bin sh, if I do env again, it should show up. Yeah, so we can see that my shell is now changed to bin sh. So that's an example of export to modify things. So generally speaking, you'll use environment variables. You might not touch them at all. You might add things like proxies, or sometimes people do account credentials. If they're running in a local machine and they need to pull credentials down for accessing things, that does happen sometimes. But basically, all it is it's a variable at an operating system level that anything can access and can be used for just defining useful information that programs want to know. Hopefully that answers your question, kind of long-winded.
Awesome. Good job, thank you.
I have one last question for you.
Yeah, sure.
Is this machine with multiple escalations a VM that you've built?
Yeah, this is a VM that I built myself. So
do you mind releasing it?
Yeah, I'll see if I can get OV if it's saved. I have some snapshots at work, but I'll get in touch with you guys. So yeah, look out for that. You can mess around with some Python module hijacking. Be fun time.
Awesome. Thank you so much again, Sam. That was fantastic, and we appreciate having you here to present for us.
Yeah, thanks for having me, guys. I hope everyone else enjoys the rest of Digital Overdose Con. I'll be around. Say hi. Enjoy the other speakers. It's going to be awesome. Bye, guys.
All right. Bye.
Bye.